So let's do the first question on the practice final. So this is going way back to the very beginning of the semester, questions about limits and continuity. So I'm going to give you a discontinuous function and ask you to analyze its continuity, in various ways like we used to. So the function that we're going to use, it's not something we've seen a lot in class, but in math in general, it's a fairly common function. It's called the floor function. So just look at the definition first. So the input, of course, is x, and the output is the greatest integer less than or equal to x. So here are some examples. Right? An integer just means a whole number, possibly a negative one. If you put in 4.8, then it basically just throws the decimal part away, right? So pi is 3.14, it goes down to 3. It's a little tricky with negative numbers. Let me give kind of an explanation of what happens here with this negative 0.1. So let's say that here is negative 0.1 and here is 0 to the right on the number line, and to the left is negative 1. Okay, so why is it going down? It's because it's the greatest integer less than or equal to x. So it's not 0 because 0 is actually greater, right? The biggest integer that's less than it is negative 1, and so that's why this is true. Alright, and so here's the function that we're going to be looking at. Right? So it is the floor of a number plus the floor of the negative version of that number. Alright, so, you can't go to a ball game without a program, and you can't answer questions about continuity unless you know what continuity means. So if you can't answer A, how are you going to do anything? So you've got to know what the definition of continuity is. So it says, give the formal definition of f of x being continuous at x equals a. Well, let me just remind you that that means that the limit as x goes to a of f of x exists and it's equal to f of a. So, in words, what this means is that if f kind of suggests that it's going to do something at a, like this is what f does around a, right? Then it actually does it. So it doesn't kind of tease you and do something else at the last minute. All right. So let's just look at b here. So remember, we have left-hand limits and right-hand limits. So this is a right-hand limit. So the plus sign means what happens as x approaches 2 from slightly to the right. So let me kind of amend my number line here and show you again the picture of what a right-hand limit looks like. So here is 2, and there's maybe you can imagine there's a y-axis and f is doing something up there that we can't see. But oh my god, it really depresses me when my handwriting is so bad that it can't be recognized as a geometric shape. I give up. So what we're doing when we take the right-hand limit here is we're approaching 2 from the right-hand side. Okay, so that means that we're basically looking at numbers that are a little bigger than 2. So let's just imagine that x is a little bigger than 2. So like 2.1. This function, the floor function, can't tell the difference between 2.1 and 2.12, right? It's not very sensitive. So if I see what's going on at 2.1, it's going to tell me what's going on for all the numbers that are just slightly to the right of 2. You can't tell the difference between them. So what is this function f doing at 2.1? Let's see. So f of 2.1 is equal to the floor of 2.1 plus the floor of negative 2.1. Okay, so this is a little tricky. What is the floor of negative 2.1? It's not 2. It's not negative 2 because negative 2 is actually greater, right? The floor has to be lower. So it is negative 3, and this is 2. Okay, so these things add together to be negative 1. Okay, so this is the answer to part A right here is negative 1. Great. Let's get that out of the way. Now let's check out the left-hand limit. And so, you know, the left-hand limit is going to be creeping up on 2 from the other side. So, again, you know, this thing can't tell the difference between, well, as my example of a number that's just slightly less than 1, I'm going to use, sorry, slightly less than 2, I'm going to use the number 1.9. Okay, so 1.9 is just slightly less than 2. So this negative sign means we're looking at numbers slightly less than 2. So let's see what happens slightly to the left of 2. Put in 1.9 and I get the floor of 1.9 plus the floor of negative 1.9. Alright, so this one is easy, right? Floor just throws away the decimal part, so this one is 1. And what is this? It's not 1 because, it's not negative 1 because negative 1 is actually greater. This is negative 2. So we've got 1 plus negative 2 is negative 1. Okay, alright. So negative 1 was also the answer for part B, which is good. So what that means is that the left-hand limit agrees with the right-hand limit. So what happens when the right-hand limit agrees with the left-hand limit? We don't even have to think for part D here. It just means that the answer to part D is the limit at which the left-hand limit and the right-hand limit agree, or the number at which the right-hand limit and the left-hand limit agree. So it is negative 1 also. Okay. So if you don't know what I'm talking about when I say the right-hand limit and the left-hand limit have to agree for the limit to exist, then you seriously need to read the book. It's definitely worth your trouble to get that straight. And I'll move this down. Well, I don't have to, do I? Now let's see what f of 2 is. So we've been looking at what happens around 2, so let's take a look and see what happens at 2. So it's the floor of 2 plus the floor of negative 2. Well, as you can see from the example here of 4, the floor function is really boring when you put in an integer. That actually doesn't do anything. So the floor of 2 is just 2 because 2 is already a whole number. The floor of negative 2 is just negative 2 because negative 2 is already a whole number. So this is 0. Alright. And so if you remember the definition that I gave for continuity, maybe I should grab it here. I'm going to take it up there where I can play with it because it's really relevant for this last part. It says, is f continuous at x equals 2? Well, it's not, right? Why not? Basically because f of 2 is not the limit as x goes to 2. We saw that the limit as x goes to 2 is negative 1. However, when you actually plug 2 in, 0 comes out. I actually want you to say something like this, like what kind of answer would be okay for f. So what I want you to write, if something like this happens, and so this is the reason why it's discontinuous at 2. The reason is that the limit as x goes to 2 of f of x is not equal to f of 2. Right? And that's it for this problem.